Alright, good morning. And this section of the tutorial is purposed for the 16A content team of CSM so that we have a general tour guide on what the 16A overleaf project structure looks like. Your course's project structure might look like ours, but it's not a guarantee, so if you want to learn about your course's project structure in CSM for content creation, please contact your seniors. And this version of the tutorial is once again only for the 16A content team. So you can see that I have censored the URL here because it is a project that is shared by link, which we would not like to expose to other people. So please do not share this link. I think it was censored in the video. Yes, it was. Okay, so entering the what is this here? Entering the project, you will see a folder called CSM16A. This is going to be changed to SB23 or whatever code your semester has. If you click out, there is going to be a couple of things we can look at. So let me first show you through what these folders are, and then we'll talk about how to compile a worksheet. So first of all, here are some draft files that are left over from last semester that can be deleted in later generations of the project architecture, so I'll not talk about it. Here's a demo section from which I'm going to show you how to do or how to compile worksheets later. There is also a final worksheet solution, which is once again a leftover. There's a Q tester, which I'll talk about later as well, and it's pretty useful. Its general purpose is to have you test the questions that you're currently writing individually. Okay, now here comes the essence, which is the question bank. What the question bank involves are folders and question tech files. Each of these question tech files stand for one CSM worksheet question. And here are some past midterm questions here as well, which I have migrated to here. The way that these midterm questions are migrated are that we retext the question prompt, but write the solution ourselves. In each of the question texts, you can also see that the newer versions have a preamble written with LaTeX comments that show who is the mentor that wrote this question, so we can reference the mentor later. So for example, in the midterm version of preambles, you will see that we also have a question source quoting previous exams, and we also have several different ways to reference the exam that offered us the midterm 2 question that we can use for practice worksheets. So we also have some figures here that we should talk about. When you see some folder that has the format of Q underscore question name underscore figs, it means that this is the folder containing the figures that you use for the pre-addressed question. For example, QGPS figs is used for a question that is QGPS, and if you try to search for the \input commands or \include graphics, they might use this instead. Then you can see that we are referencing figures from the QGPS figs folder. So this is how, once again, we can organize the structure of a LaTeX project folder. As you can see, there are a couple of figures here. Now, it's okay to use pictures as figures. For example, some of the questions here that has circuits also has circuits being pictures instead of the LaTeX diagrams that we've written before. But generally, if you're trying to create CSM content, it is most encouraged of you to still write out circuit diagrams, so it's easier to edit because, as you know, it is very difficult to edit pictures, especially pictures of circuit diagrams. Alright, so now that we have briefly mentioned question bank, there's also a special folder of figures that I'd like to go through, which is this 11A cookbook figures. What this exactly is the chart of all inverting amplifier architectures that you see in EEC16A discussions. So, for example, if I search up, I think it was discussion 10B from EEC16A. Maybe it is not 10B, but 10A. Anyways, in one of the discussion, they gave you a table of inverting amplifier architecture. Should be 11A then. Okay, I wonder if they still give you those, but what this is supposed to be is a cookbook of the different figures of amplifier architecture. So for example, you can see cookbook, or in general just templates of circuit diagram LaTeX text that is equivalent to a current divider, voltage buffer, or even these amplifier structures. So for example, I can go into one of my documents and try to show you one of these. Here I'll input the diagram that is inverting amplifier without reference voltage, and we'll wait for it to compile for a bit. In the meantime, let me also mention what the rest of the folders are. So this template folder is supposed to be a good tool when you are trying to create a worksheet, a series of worksheet files, which, as you see, involves all of these files when compiling. So then, these week 0, week 1, blah 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 folder will just stand for the worksheets from week 0 to the week that it labels. And here's also week M1 and week M2, which are midterm 1 and midterm 2 folders. This is a folder that was used for someone else's personal purpose. I'm going to delete the folder here. Which, as you can see, Overleaf also has a function to delete all of your prior hard work. Pretty human. Okay, here's also a CircuitTix simple tutorial structure that can let you know what can CircuitTix do. I am not entirely sure why as you can see, the project architecture still has a lot of leftover files from the previous generations. Okay. So here's the important part. In the previous tutorial from the CS70 node architecture, we see that .sty files are useful for marking the style of a node. So in this case, CSM16.sty is the style file for a worksheet, which decides how a worksheet will be shaped, what is its general graphic template, and what will be the fonts and different text options and packages that we involve. Here's also fa22.sty, which stands for the general style edition that we have in fall 2022, which, as you can see, I added in some efforts from the CS70 packages. Last but not least, here's also markup.sty, which is used for markup in our LaTeX file. There's also a README that is just not completed and is also a leftover, and timestamp should also be a leftover. Okay, so now that we have went through all of these chaotic things, and we have also seen that the input command works for the question bank figures, let's talk about how to write questions in LaTeX. So to write questions in LaTeX, what I can do is first create a file that resembles a question in our question bank folder. In this case, I'm going to call my question q underscore, which is the general prefix of question files, and then let me say tutorial. So I'll create this q underscore tutorial.tech file, which will take a while because my Wi-Fi is very slow. And then we can scroll down to find q underscore tutorial. Here. Okay. So the tester document then is for you to look at the content of q underscore tutorial while editing. So this is very alike to how we have inserted graphics using \input and then compile the main document while editing graphics. This is the same logic where instead of compiling and editing graphs, we compile and edit individual questions and see what happens. So it is also notable that the tester document mimics a worksheet setup. So if you use if you're using q underscore tester to test your question, you will see something that mimics a worksheet setup. And we'll see that the actual worksheet setup is actually more complicated, but this is a mimic, so no one expects too much out of it. Okay, so it is also notable that each question has a general template to follow. For example, I should first write out a preamble, which I'll just copy mine somewhere within here. I should have written a question somewhere here. This is probably my question. So after the file finishes loading, I'll then copy paste the preamble of a question that marks the author into my Q_tutorial, and then I'll have to also type in general the question title, the subparts of a question, as well as the contents of a question. For some reason, the Wi-Fi is not quite stable today. Alright, here we go. So I'm going to copy paste the author amble, as well as the question title, which we can type using the topic /QNS. So as you can see, I have very creative puns. Let's call the question tutorial. And let's compile and see what happens to the main document, which to use QTester, you should also set your main document as QTester so that it's actually compiling the tester document instead of some other thing. So let me try to find QTester, which should be somewhere around here. So we're using tester. Tester and nozzle is for you to see just the question. Tester is for you to see both the question and the solution. Okay, so it's saying that Q tutorial tech is not found, and the reason why is because I typed the address of the input argument wrong. Ha 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 ha. So I'm going to come here and auto fix a little. Right. So now let's recompile the file and see what happens. Okay, so as you can see, the worksheet title does not come out, but we do see a worksheet styled question title that just says tutorial. Okay, so after tutorial, let us also reference the question before. In each tutorial, not in each tutorial, in each question, there are a couple of things that we would like to comment. First of all is the learning goal of the question, which I'll also just copy paste here for the sake of saving time. So a learning goal can be written in plain text as well as in lists, in a list of bullet points. So currently my preferred way of using bullet point is the custom environment that I inserted into the CSM library, which is called Dun-Ming. It works exactly like enumerate, except it has a special trick that I'll let you see later. So for example, the learning goal of this might be learn how to create a worksheet question using LaTeX. Okay, let's Control S and see what happens. As you can see, we now have a learning goal, which also has a bullet point with a vertical bar beside it. Let me show you what happens when we have more items. Learn how to calculate the determinant of a matrix, for example. And then I can also have a lower Lipson item here. And let me show you what happens when Dun-Ming has multiple items. The vertical bar extends, which is I think it's aesthetic enough to be put into content, so I did that. Okay. Then I can also have some other explanations about what the question is about. So for example, tutorial is a question that is a question. Tutorial can have difficult mathematical properties. And then sometimes before the question, you might want to offer either a context story for your problem or some explanation or basic review. So in this case, what I can do for a basic review is I can use my previously written custom environments as put in full 2022 style from my CS70 worksheet. As you can see, there's an environment called LN theorem, which talks about a theorem. So I am going to use that. Theorem of tutorial and LN theorem, and I'm just going to put whatever I should here. For example, maybe I can say that the theorem that I'm talking about is that for old tutorial, if the tutorial is 10 minutes, it is short. Okay, and then I can also have a couple of other mechanisms for me to offer more information about the theorem. For example, TCB lower allows me to put a dashed line at the position this command is inserted in the LaTeX file, and then I can talk about another part of the theorem, for example, maybe the proof. Okay, let's compile and see what happens. So as you can see, a theorem box is inserted right below. And now that we have finished describing the question, we can now start writing the question, which the subparts of a question should be labeled using not this part. Let me scroll down a bit to let you see. Using an enumerate environment and using some other sub-item comments that we'll talk about later. So let's first begin an enumerate environment to write our subparts of the question. Okay. And then I can write the questions. So each question each subpart of a question approximately contains 3 parts. One is item, which is the question content. Another is meta, which is advices for mentors teaching this problem. And last but not least is answer, which is written by the ans command. Let's compile this to let you see what happens here. So as you can see, there's question content, there's meta, which stands for advices for mentors teaching a problem. There's also answer, which stands for a solution of a question. So I can just copy paste the subpart a bit. For example, if I want 3 subparts in the question, I will then copy paste this 2 times, so that I have 3 sub-items to work with. Okay, so as you can see, QTester Sol gives you all of the meta and solution of your question. What about tester no sol? What tester no sol does instead is, let me compile and let you see. Tester no sol just shows the question instead. So this is what your student will see. Essentially, no sol is what your student will see, and tester is what the mentors will see. Okay. It is also notable that in each of the worksheet from CSM, which you can see from CSM scheduler, takes a bit of time to load. Essentially, each worksheet has 3 versions of presentation. And if you click into CSM scheduler and click on resources for 16A, for example, you can see that there's a question file and a solution file. But the solution file that your student receives is different from the solution file that the mentors will receive. The students will not see meta, but your mentors will see meta. So as you can see, this is an example question that uses both the box and binonym with learning goal, and some annotation on the question solution. You can look at this on your own time. Okay. You can also see that there are some other links here for interesting review contents. For example, here are my review videos for 16A, and here are some midterm review worksheets, which you can also see the solution at. Okay. You can also see other courses doing their thing. Okay. So this is in general how you can create questions, and as for how you can write question content, it is fairly similar to what we have experienced before, which is that we just write the LaTeX math text we want here as outlined from previous tutorial videos. So let me show you an example of a question that I wrote. Let's use spend more as our example. So I'm going to input this spend more into my nosol file first to show you how it looks. And then I'll do a anatomical analysis of the spend more document question. So here you can see this question is called spend more. Also, in general, if you're going to name your question, there's two names for it. One is the official name that the mentors will see to indicate what the question is about, especially the topic and the level of difficulty. The other is the silly title that you will use for your question. So, for example, there are also some more silly titles that we have used, such as null space concepts with the topic being null cap, which I am utterly regretful about. I am very sorry for the pun. So, as you can see, this is a no-sol file, which means all the meta and ends contents will be ignored, which is why the meta doesn't appear here, but the learning goal does. You can also just write your learning goal as plain text instead of bullet point. It depends on what you prefer. But you can also see the definition block and the symbol block we have here, corresponding position. And then you can see the questions here, which, as you can see, the meta and the ends are all ignored. So if we put spend more into a tester file, a Q-tester with solution instead, then... Oh, sorry, there's an extra .tech here. Let me stop compilation here and recompile. If you use the solution version of tester file, you'll see that the solutions are included, and the meta here is also included for mentor references. Metas are in general written in bullet points. Alright, so now how to create a worksheet. To create a worksheet, we should first, let me use the demo for example. So to create a worksheet, you would want to first copy the 4 files and body this and solution. However, you do see that there are some very repetitive parts of these 4 files, and there are also some fixes. So let me outline those fixes here to demonstrate to the future generation when they need help. So first of all, I already put these 3 lines that are repeated throughout each of the tutorial, as each of the document here, as you can see. I already put these into the fall 2022 library, so you can just delete these parts from the demo document. And then, for discussion especially, since CSM is trying to save paper, what we're going to do for answer space for students is that we're going to not give any space on the worksheet for students to answer question, and we're going to ask them to bring scratch paper instead. So the vertical space that should be taking place of the ends document to replace them is actually 0 empty space. Okay, and last but not least, the rest of the things are working well. You can also change the color of solution if you want here, but I am not in the interest of fiddling with it yet. Okay, so let's observe the solution file first. So you can see that there are some preambles. There are also some inclusion of previous packages. And then you can see \input body. So let's look at body and see what it tries to input. Here we are beginning a document, and then we're defining the title of a worksheet, which here I'll say demo parentheses tutorial. And then there are some other settings for enumeration, as you can see here, which defines the enumeration item to be first a question number, and then the subparts are written in letters. So 1A, 1B, 1C. Okay. There's also a vertical space here to separate the title from the worksheet content. And here, when we say begin Q and list, is where we insert our questions. So for example, I might want to insert a question called tutorial from before, and I might also want to insert a question about null space from before, which I will use this one. And I might also want to insert a midterm 1 question, which I can get from here. Okay, so now that I have inputted these questions into my question list, what the solution document would do is then use the question list we put in body and directly insert it into the solution document. So here's what a worksheet would then look like, especially its solution file. So as you can see, here's the title preamble. This fall 2022 can be changed in the fa2022.sty or markup.sty. You can just change the fall 22 into spring 23. You can also see the title here, the course title here. Also see last updated date here. And you can also see tutorial question, which we have here. And you can also see null cap. And you can also see different ways of enumerating items. And you can see the solution file going pretty long. Now let me also show you a couple of solutions that show diagrams. For example, maybe rotate. Maybe this rotation question can work out. Let's see. As you can see, larger questions require more compiling time. Okay, and I should have compiled at soul instead of body, because body is actually an incomplete LaTeX document. Okay, it says it cannot find the question, so let's go back and fix it. Ah, yes, it has been relocated by our colleague into some other space. Okay, and let's compile from soul.tech. Now you can see a fairly long solution that involves a lot of different plotting, which you can reference in the 16A library later. As you can see, this is a lot of plotting, and this is a fairly terrifying question. So this is in general how we can make worksheets. And if you want to make a worksheet for, say, week 14, then what you can do is first create a folder called week 14. Oh my god, I clicked the wrong button. Week 14. Okay, and then what you'll do is copy the files from here in the demo file or in any other week file into the week 14. Unfortunately, Overleaf doesn't seem to support this very well, in contrast with VS Code, which supports file copying, I think. So you have to manually type out here, which will be ends, body, soul, and discussion. Okay. So then I'm going to copy the file contents here. Answer, discussion, and solution will be exactly the same. Every time you create a new worksheet, the only thing that you should need to change across a worksheet should be the body for document, because that's where the content or the body of the worksheet comes from. Okay, let me do one last copy paste, and another one last copy paste. Here, and then since this is week 14, I'm just going to say week 14 here. Which, as you can see in week 12, we also call it week 12 instead. Okay, let's Control S and see what happens. And you'll notice that once again, since I compiled on the body.tech file, like the idiot I was, it went to the main document. So if you want to generate a document for week 14, you'll have to traverse to the week 14 file folder and click whatever you want as the main document. For example, I'm going to compile for the student worksheet file of week 14, then I will choose this, which stands for discussion. And then, as you can see, we have successfully created a worksheet that is a discussion file. Now let us see what happens with using different folders. And sometimes, as you can see, Overleaf just loses track of your original folder, so you have to refresh a little to get your original folder called week 14 back. Okay, so now let me generate a solution version. And last but not least, you can also see that to download a PDF that you just compiled, you can just press the download PDF button and rename the file later for your instructors and coordinators. And then here's a solution PDF file that you can post on CSM Scheduler.